So on the 3-2 part of your assignment, we're dealing with range and standard deviation. So the range is just where you take the largest value in the data and subtract off the smallest value in the data. So the numbers don't have to be listed from least to greatest. You just have to look through the numbers and find the biggest and subtract the smallest. Okay, so then they have our little formula, the range, my board is off, largest minus smallest. Okay, now we have something that's called a standard deviation. A standard deviation is like how much you expect things to differ, change from around the mean. So here it says the sum of all the deviations about the mean. So remember the mean last time when we talked about mean, that's where you add all the data together and divide by how many data there was. So the mean, you're taking the score, like if you're doing test scores, like a student's actual score, and minusing off the mean to find out how much it deviated, how much it was from the mean. So if the mean test score was, say, 85% and someone got a 90, then they're 5 away from the mean. If someone got, say, an 80 and the mean was 85, they're still 5 away from the mean. So you're finding the deviations from the mean. Okay, so it says the sum of all the deviations from the mean has to equal 0. So if I found the mean for the test score in this class and found everyone's deviations, people that got higher and people got lower, some of the scores would be positive deviations, some would be negative deviations. But all of those, if you added the deviations from the mean, should add up to 0. Okay, so we have something that's called the population deviation, standard deviation. So anytime it says the word population, that's the entire group that you're studying. So if the population, and my population was just the students in my 1040 class, the population standard deviation would have to have all of your guys' scores, the standard deviation from every single person. If it was the so there's the population, and then there's the sample deviation, standard deviation. The sample would just be if I just did some of you in the class and not every single person. Okay, so the population standard deviation of a variable is the square root of the sum of the squared deviations about the population mean divided by the number of observations. That is, it's the square root of the mean of the squared deviations of the population mean. And it says the symbolic notation they use is the lowercase Greek sigma. So the lowercase is that symbol right there. So if you see that symbol, they're talking about the population. You need to know that one's the population standard deviation. So that's the entire group. So they give us this great big formula to find the standard deviation. I'll be honest, I've never used that formula once because calculators and StatCrunch do it for you. Okay, so here we have the formula, but I really doubt you guys will use this, and I'll show you guys later how to do it in StatCrunch. Okay, but what it's saying is it's saying x1, if this was test scores, this would be taking, say, someone's test score. So if someone got the test score of 90, then they're doing the 90 minus whatever the standard deviation or the mean was. And if the mean average test score was 85, you're subtracting those scores and then squaring it. Then you're going plus, and then you take another student's in the class's test score. Let's say someone got the 80, and then you're minusing the mean of 85, squaring it, and then you're going plus, and then you take another student's test score minus the 85, then square it, and you do that for every single person that took this test. It does. It sounds miserable. That's why I've never done this formula by hand because I just type the data into a calculator or use StatCrunch and it gives you the answer. And then after you've added those all up, then it says you divide by n, where n is how many people were there in the data set. And then that gives you that standard deviation. Okay, now the sample standard deviation is where you do that same similar stuff, but they're going to use, instead of this symbol here, if it's the sample standard deviation, they're just going to use an S. So you have to know, in my math lab, it says S equals, they're talking about the sample. So this one is the sample's standard deviation. So for the sample one, where you're not doing every single person in the class, you just pick like say 5 people or something like that, and you just do theirs. It says it's the square root of the sum of the squared deviations, just like what we talked about before, and then you divide it by n minus 1, where n is the sample size. So you do 1 less than the sample size. So if you had 5 students in your sample, you would do divide by 4. Okay, and then it says the n minus 1 is called the degrees of freedom because the first n minus observations have the freedom to be whatever value they wish, but the nth value has no freedom. It has to be whatever value forces the sum to equal 0, because at the top of the page, we said that the sums of the deviations always has to be 0. So that last one has to be whatever makes everything add up to 0. Okay, now variance. Variance is related to the standard deviation. So the variance is just if you square the standard deviation. So on this page where it gave us the formula for the standard deviation, notice the standard deviations always had a square root on it. So if you square it, it gets rid of the square root. So it's basically the standard deviation without the square root on it. Okay, and that's what they call the variance. Okay, so the population variance, again, for standard deviation, for the standard deviation, they use that Greek sigma. So if they want you to do the variance, they're just squaring it. So that's sigma squared. And then if it's the sample, S was standing for the standard deviation of the sample, so then they square it, and then you have the sample's variance. Okay, so this one says the following data represent travel times in minutes to work for all 7 employees of a startup company, web development company. So it's saying one person takes 23 minutes to drive to work, one takes 36, one takes 23, one takes 18, and so on. Okay, now I could go through and find the mean and do all of that stuff by hand, but I'm not going to. So in StatCrunch, I'm going to show you how to do it in StatCrunch. I'm going to pause it real quick, and then I'll pull up StatCrunch. Okay, so to use StatCrunch, instead of using these numbers right here for this problem, I'm going to go, I found one on your assignments, question number 4, where they ask us to come up with the sample variance and the standard deviation. So again, when you have StatCrunch, it will have this little box right here. So I'm going to click on that box, open in StatCrunch. And then it automatically put all of the data there for me. And then once I have the data there, oh, I thought on one of these pages I told you the steps. Oh, maybe it's on the next one. I got better about writing the steps in the notes, but it's probably on the next one. Okay, so then once you have it, your StatCrunch, then I'm going to go Stat, and then I'm going to go to, let's see, so Stat, Summary Stat. The information was in columns, so I'm going to click on columns. It was in variable 1. That was what this column right here was titled, so I select that. And then I tell it what I want. So notice over here, it already says the variance is already selected, standard deviation is selected. So those things are already selected. If I needed something else that wasn't selected, then I just scroll down here and it gives me other options. I also have this, another standard deviation right here. Okay, so then I hit compute. And then notice if I needed the mean, it's telling me the mean. If I need the variance, it's telling me the variance. If I need the standard deviation, it's telling me the standard deviation. If you don't want it to give you all of that data, then you just select the ones you want. I personally don't care if it gives me more data than I need, but so I usually just leave it with what it already gave me if I don't need more data. I just leave it all. And then I have that information. Okay, so then the sample standard deviation, it says technically you would need to take a sample from the population, okay, but I'm not going to go and do a population from that. I just did the whole thing. Okay, and then we get the mean and the variance and the median. That was all just listed right there in StatCrunch for us. I do want to mention how you would do that on a graphing calculator. So most of the stuff, we're just going to do it in StatCrunch because a lot of times you guys have a ton of data, but just be aware everything that you're doing in StatCrunch, if you have a graphing calculator, you can do the stuff there too. You just probably won't. But on a graphing calculator, to get the data into the calculator, you hit the Stat button and then Edit. And then like clear out whatever data is already in your columns if you have any. So I can just hit clear and enter and it wipes out the data that's already there. And then what you have to do is you have to type in all of the data that they give you. So I'm now just typing in the ones right here for this startup company because it's right in front of me. So you have to type in all the data. And this is why we'll usually just use StatCrunch because StatCrunch automatically just pulls the data over from your problem. And then you don't have to risk typing a number wrong or leaving a number out and getting the wrong answer. But once you have the data in your calculator, then you hit Stat, arrow over to Calculate, and then I want one variable statistics. And then I'm telling it came from list 1 because that's what I edited. And then I just calculate. And now it gave me all of this information. So the X with the line over it tells me that's the mean. The little summation symbol in front means that's what you got if you added all the data. The S with the X, that's the sample standard deviation. The one with this little sigma, that's the population standard deviation. And then it has like even more information here. So your calculators can also give you the information, but you risk getting wrong answers if you type things in the wrong way. Okay. Okay, so when you have the data, it says from this obtain, before I do that, if I wanted the standard deviation, again, the way you get the standard deviation is if you're going to use the calculator, again, it's Stat, Edit, and then you have to type in all the data. Since I have to type in all the data here, or in StatCrunch, I have to type in all the data because it's not already preset. You just type in all the data you have, and then after you have all the data, you just do what I just previously showed, and I'm going to pause this while I type it in so people in the future don't have to sit and watch me type all the numbers in. Okay, so once you have all the data in, again, to get the standard deviation, I would hit Stat, arrow over to Calculate, one variable Stat. I typed it all under list 1. Okay, so now my population standard deviation is 1.53. Now it gave me a sample standard deviation. It's slightly different because remember the formula for the standard divided by a different number, 1 less than. So, but this one was the population, everyone in the class. Now, if I wanted to do a sample, so I'm going to write down that the standard deviation was 1.536. If I wanted to do a sample from the students in the class, let's say I wanted to sample 5 students and then see how the standard deviation. The standard deviation should, from the sample, end up being kind of close, but it's not going to match exactly. So to get a sample from here, I can go math, probability, random integer, and I had 1 to 29 students. And let's say I'm going to choose 5 students. So I'm choosing students number 1, 16, 25, 29, and 9. Drag that right there so I remember which ones I'm going to do. So then if I wanted to do my another one, I could go Stat, Edit, and now under list 2, I could enter the data for student 1, which was 7.5. Student 16 was 9. The shoe size for student 25 was 7.5. Student 29 was 10.5. And student 9 was 9. So now if I wanted the standard deviation from this, I can hit Stat, arrow over to Calculate, one variable Stat, but now it's list 2, so I change it second number 2 for list 2, and then I calculate this. And now it tells me my sample, this is a sample now, it wasn't the whole thing, my sample standard deviation is 1.25. So it was close. 1.53 was the population. The sample was near it, but it's not exact. If I did this again, selecting 5 different students and got their standard deviation from that sample, again, it's going to be different. It will be should be kind of close to the one I got here, but it's not going to be the same. Okay, so depending on the sample you choose, your results are different. So when people like do real surveys and gather the data, they present their stuff saying, well, based on the whole population, this is kind of what we expect, but there's always going to be some variability because it's not perfect because it's just from a sample. Okay, so but it should give you an idea of what you would expect overall with the whole population. Okay, now the empirical rule. So if it says to use the empirical rule, what it's doing is that standard deviation that I was talking about, we have these little charts, little bell charts, bell curves. This is like a normal curve. The middle line, when we talked about bar charts and stuff, I said that highest peak was the mode, the most. If the data is normal, where you have this nice symmetry going on, this middle, the highest, is your mode, but it's also your median. Mean, median, mode, missing mean. It's also the mean. So if it's a nice symmetrical thing, it doesn't matter if you're calling that the mode, the mean, or the median. I usually just call it the mode. Okay, I mean, I usually just call it the median. Median is what I usually label it as, but it doesn't matter because it's the same. We saw it last time when you have those little tells, then it's skewed and the mode is still in the middle, and then it's the median and then the mean. Okay, but if it's all perfectly symmetrical, those line up right there. So the mean is where you add everyone's up. So let's say you guys just took a test, and let's say I figured out the mean test score for the class was 85. And then we figured out the standard deviation. And I would do it on the calculator. And let's say the calculator then told me that standard deviation, I'm just going to pick nice, easy numbers. Let's say it told me the standard deviation was 5. So then when I draw this little chart, I draw it off of based on the standard deviation number. So if my mean was, in the symbol for mean, if it's a sample, it's an X with the line over it. If it's the population, it's the little mu symbol. And then let's say my standard deviation, let's say our standard deviation was 5%. So then I would take my mean of 85 and I would add 5 to it and get 90. And then I'd add 5 to it and get 95. And then I'd add 5 to it and get 100. And then I'd go this way. I'd be minusing the mean. So I would minus the 5 and get 80, minus the 5 and get 75, minus the 5 and get 70, and so on. So we usually add by whatever the calculator or StatCrunch tells us that standard deviation is. So then we have something that's called this empirical rule. We expect about 68% of the data to be within one standard deviation of the mean. So up here, it's saying within one standard deviation. So when you take the mean and add the standard deviation and take the mean and subtract the standard deviation, you expect from here to here to be 90 or 68% of the data. So that means if this right here was my curve, I would expect 68% of the students in the class to have gotten a test score between 80 and 90. That's basically what it's telling me. And then 2 standard deviations above and below the mean. If I added the standard deviation twice, I would get up to the 95. And if I subtracted the standard deviation twice from the mean, I'd be down to 75. So I would expect, the next one is 95. It says we expect 95% of the data to be within 2 standard deviations of the mean. So that means on this particular test, I would expect 95% of the students in the class to have gotten a test score between 75 and 95. And then 3 standard deviations above and below the mean. It says 3 standard deviations above and below the mean. You expect 99.7% of the data to be within 3 standard deviations. So I would expect 99.7% of the students to have gotten a test score between 70 and 100%. Now this is approximating the answer. So if your assignment tells you use the empirical rule, you have to do it this way. There is a way you can do it in StatCrunch where it gives you like the exact, what you would expect. But if it says to use the empirical rule, those numbers that the exact answer that you would get using the StatCrunch or the calculator are too exact, and it won't accept the answer. So if it says use the empirical rule, you have to know these percentages. Now, the nice thing is you guys have those reference sheets that I gave you that you have available on your test. They tell you on that reference sheet what these percentages are. They just don't draw the curve for you. So if you find those reference sheets, it does tell you under chapter 3, so it's on that first page, right before where it says chapter 4, it has in bold, it says empirical rule, and then it tells you approximately 68% of the data lies within 1 standard deviation of the mean. Approximately 95% of the data is within 2 standard deviations of the mean. Approximately 99.7% of the data is within 3 standard deviations of the mean. So it tells you that information, but it doesn't give it to you as the graph. Now, sometimes we need more detailed stuff. We don't want just within 1 standard deviation. Sometimes they might say, what percent of students would you expect to have a test score between, say, 85 and 90%? Well, if I know within 1 standard deviation of the mean, if that's 68%, if I cut that in half, half of 68% is 34. So I would expect 34% of the students to get a score between 85 and 90%. I would also expect 34% of the students to have a score between 80 and 85. Now, if they said, what percent of the students would you what percent of the class would you expect to have a score between 90 and 95% of the data? Well, I know within 2 standard deviations of the mean that that's 95% of the data. Now, everything in this curve adds up to 100%. So if I did, first off, went 95 minus out this 68%, this middle part, then I would be left with the total percent between the 75 and the 80 and between the 90 and 95. So I would just go 95 minus 68. Whoops, I don't want 2 minuses though. And 27, divide that by 2 because half of the data is going to be on the left, half of it's going to be on the right. So I would now expect 13.5% of the class to have a test score between 90 and 95, and I'd expect 13.5% of the class to have a test score between 75 and 80. And then if I wanted to know what percent of the class you'd expect to have a test score between 95 and 100, well, it says within 3 standard deviations of the mean, it's 99.7%. So if I took 99.7 and minused off this whole middle chunk, the 95% that I've already broken off, then these 2 end pieces right here between 75 and 70, at 70, 75, and 95 and 100, it has to be 4.7. So I half that. So each little chunk is 2.35. So I expect 2.35% of the students to get between 95 and 100, and 2.35% to get above between 70 and 75. And then these last little tells over here, because everything has to add up to 100%, I'm only at 99.7, so if I did 100 minus the 99.7, I still have 0.3 left. If I divide that by 2, I would expect 0.15% to have a score less than 70% on the test, and 0.15% to have greater than 100% on the test. So maybe the teacher offered extra credit. Okay. So now they could ask me a wide variety of questions, and they could say, well, what percent of the students would you expect to have a score between 70 and 90? So then I could find my 70 and my 90, and I would just add up all of these percentages in these sections together, and then I could tell you what I would expect to be between 70 and 90. So if they say using the empirical rule, you want to draw this chart out, put the mean that they gave you in the middle, and then whatever the standard deviation is, add by the standard deviation to get the numbers, and subtract by the standard deviation, and then you use this chart. So if I were you, I'd make sure in your notes you have all of these percentages listed. So if you have these questions on your assignment where they want specific things, these percentages don't change if you're using the empirical rule. Okay, and then they're close to what you would get if you did it like in a calculator and stuff, because they don't always have to ask you at these nice standard deviation spots. They could say, what percent do you expect to get a score of between 92 and 96? So on this assignment, they're not going to, but in the future, they could ask you at things that aren't at these nice spots here, and then we would use StatCrunch or tables and charts to get us those other answers. But again, if it says the empirical rule, you're using this information here. Okay, so this one says vending machines can be adjusted to reject coins above or below certain weights. The weights of the illegal U.S. quarter are normally distributed. So if I see that word normally distributed, that means I can draw one of these nice normal curves. So there's not going to be a tell. And then I know the middle of this is where I would expect the mean to be, or the median, or the mode. I'm just going to label it as the mean. Because then it says with a mean of 5.67 grams. So this number would be 5.67. And a standard deviation of 0.07. So that means what I'm going to do to come up with these next lines is I'm going to add by 0.07 and I'm going to subtract by 0.07 starting with my mean. So I'm going to take my mean, 5.67, and whoops, get 7 in there, and add the standard deviation of 0.07. I don't need to put the zeros behind there, the other zeros, because that's going to be the same as just 0.07. So then my next number will be 5.74. And then I'll add that standard deviation again. And then the next line will be 5.81. And then I add the standard deviation again. And I get 5.88. Usually we just draw 3 lines above the mean and 3 below, because out here at these little tells, it just gets so small. So we usually don't keep adding the standard deviation. We usually just go out 3. And then to get the numbers the other way, again, I'm going to start at the mean, 5.67, and now I'm going to subtract off the standard deviation. So then I get 5.6, and then subtract off the standard deviation, and I get 5.53, and then subtract off the standard deviation again, and I get 5.46. So now it says if a vending machine is adjusted to reject quarters that weigh more than 5.81, so 5.81 was right here, so more than that, it's talking about all of that section there, and less than 5.35. So here's my 5.35, and it said less than that, so it's talking about that section. What percentage of legal quarters will be rejected by this machine? So using this chart that I drew over here, I know that it goes 34, 13.5, 2.35, and 0.15. So I'll go ahead and write that in. So this was 34. This was, the next one says it was 13.5. And then we have 2.35. And then we have 0.15. So then this one right here would be the 2.35. This one would be the 0.15. Okay, and I don't really care about those other ones because it wasn't the shaded. So then to answer this question, I just find the percentages in that little shaded section that it cared about. So I would just add them together. So I have the 0.15 from this lower end, plus the 2.35, and then plus the 2.35 at the top, plus the 0.15 from the top. I'm missing a plus sign in between these two over here. And then I just add those together. So I'm expecting the machine to reject 5% of legal coins because it's not within what they put it. Another way I could have done that is I could say, I know all of this has to add up to 100%. So I know 2 standard deviations below and 2 standard deviations above, this section that they don't care about, I know is taking up 95%. So I could do 100, the whole thing, minus this 95% middle section that I didn't want, and then I'm left with the 5%. So both ways work, it doesn't matter, but you come up with the same answer either way. But again, these percentages aren't going to change. So when it comes test time, if they ask you on the review things about the empirical rule, you would either want to memorize these individual little percentages or look on your reference sheet and pull the numbers that they did give you, the 68, 95, 99.7, and then know how to create those yourself. Okay, so on the 3-3, says we've discussed how to compute descriptive statistics from raw data. That would be like finding the mean, the median, the mode, the standard deviation. But often the only available data we have has already been summarized in frequency distributions or grouped data. So that's kind of like maybe you don't have the raw data, you don't have everyone's shoe size, you don't have everyone's test scores. You just have the summary of the data. So maybe if we were dealing with like test scores, maybe you only had a chart that said people between 0 and 9% on the test. There were no students, hopefully. Students between 10 and 19% on the test. Maybe there was like one student. Students between 20 and 29% on the test. Maybe there was no one. And then you have all of this data. And then eventually you have the students between like 80 and 89% on the test. Maybe there were like 10 students between 90 and 99% on the test. Maybe there was 3 students. The last one would have to be 100 to 109% on the test and whatever. But you only have this. So you don't have everyone's individual test score. You only have like this data that's already been grouped for you. So on this one, we'll talk about how you can come up with information from the grouped data, if that's what you have. Okay, so we have what's called the weighted mean. So again, the mean, symbol for mean, an X with a line above it. If they do the X with the line above it, that means it's from a sample. If they do it this way for the mean, the mu, then that means it's from the population. So they're doing the mean, and then they have a little W for the weighted mean. It says of a variable is found by multiplying each value of the variable by its corresponding weight, and then adding them together, and then dividing by the sum of all the weights. And I have an example down here that'll make that make more sense. But this is our formula, where the weight is the weight of the ith observation. So that's like the weight like of the first item in the list, and then the second item, and the third item. This isn't talking about like the weight where you stand on a scale and get the weight, but how much value something's taking. Okay, so to compute a weighted mean, it says Bob goes to the by the weight nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate covered peanuts, and 1.5 pounds of cashews. Raisins cost $1.25 per pound. Chocolate covered peanuts cost $3.25 per pound, and the cashews cost $5.40 per pound. What is the cost per pound of this new mix? So what we have to do is we have to take how many pounds he bought of the raisins, and it says each raisin costs you $1.25 per pound. So we have to times how many pounds of raisins with the cost of the raisins. And then you have to go plus, and then you have to take how many pounds of the chocolate covered peanuts and times it with the cost of the chocolate covered peanuts. And then you would go plus, and then you would take how many pounds of cashews he bought and times it by the cost of the cashews. And then you would know the total cost that you spent. And then we want to know cost per pound. Well, in math, per usually means we're going to divide. So you're going to take your total cost and divide it by how many total pounds did you buy. So he bought a total of 1, 2, 3, 4.5 pounds of stuff. So his total cost divided by how many pounds. So this right here is showing those computations, and I saw a lot of you grab your calculator, so hopefully you were coming up with the same thing. So you take, again, the pounds times the individual cost of each item, added it together to get your total cost on the top. So your total cost that you spent at this store is $15.85, and we're not dealing with tax. And then you bought 4.5 pounds worth of nuts, you divided them, and it's $3.52. So this new nut mixture is now $3.52 per pound is what that cost would be. Okay, so we can have weighted means with the sample and the population mean. It's the same type of thing. You're taking and you're multiplying. It says xi is the midpoint of the value in the class. So when you have the class, so here I have a little example. Remember, class is like this category. So this says this is the National Survey of Student Engagement in a survey that, among other things, asks the first-year students at an art college how much time they spent preparing for class each week. The results from the 2007 survey are summarized below. Approximate the mean number of hours spent preparing for each class. So it said 0, you spent no time preparing for this class. No one said they spent no time preparing for their class. They spent 1 to 5, is this in minutes? Probably. It doesn't tell us if that's in minutes. Hours, did it say hours somewhere? Okay, yeah, approximate the mean number of hours. Okay, so spending 1 to 5 hours, 130 people said they spent between 1 to 5 hours. 250 people said they spent between 6 to 10 hours preparing, and so on. So we have the data. So it says the x sub I in the formula is the midpoint. So the midpoint would be the middle number between 1 and 5. So if I had 1, 2, 3, 4, 5, let's see here. How come they don't have, why is it 3.5 instead of 4? So I'm not sure why they said the midpoint was 3.5, but anyways, they're taking that whatever they determined the midpoint was, and then they're taking, this formula says once you have the midpoint, then the formula says you take that midpoint and multiply it by the frequency. So this next column is taking the 3.5 and timesing it by the frequency of 130. So if I want 130 times 3.5, we get 455. And then if I took the frequency on the next one of 250 and times it by what they said was the midpoint, 8.5, I get 2125. So then the formula says after you do all that multiplication, you're supposed to add, the top of the fraction says we're going to add them all together, and then we divide it by the sum of all the frequencies. So then at the bottom of the chart, if you added all of these right here together, we end up with this number here, and then you divide it by the sum of all the frequencies. So if you added all these numbers frequencies together, you get 1,000. So then over here they divided those two numbers, and then they get the 14.75 as the weighted mean, or the weighted, sorry, that's the weighted standard deviation, because that's the formula for the, no, that's the formula for the weighted mean, okay? But again, you guys aren't actually going to have to do that because I'll show you how to do it in StatCrunch. Okay, now they have another formula when you have these weighted things to come up with the standard deviation and the standard deviation, the population, and the sample. So they're taking, again, x, they're taking the observation minus the mean, because that's how we do the standard deviation, and then they times it by the frequency, and then they add them all together. This little symbol right here means add your stuff together so they don't have to keep putting the plus signs. And then you divide it by the sum of the frequency over here if it's the population. And then on the sample, it says it's the sum of the frequency minus 1. So this is still the same information from the previous page, but now they're doing it to come up with the standard deviation. So on the previous page, we came up with the mean. It said that the mean was 14.75. That was the number that we got right here. So then to do the standard deviation, they say you're taking the observation, the 3.5, minusing the 14.75 to get this, And then once they had that number, then they squared it and times it by the frequency, okay, to come up with the numbers over here. And then once they had all of the numbers over there, they added them all of these numbers right here together to come up with this number. And then they divided it by the sum of all the frequencies minus 1 to come up with the sample um, standard deviation. Again, we're going to use the StatCrunch to do all of this. But this is what the formulas are. Not very fun to use. Okay, so now how to do this in StatCrunch. I'm not sure which question number it is because I didn't write down the question number, but I do have the item code. So whenever you guys go into your questions, it always lists off. This right here means it comes from the 3.3 section. And then from their bank of questions, it was the fourth one in their bank. So it might not be your number 4 question because they might have only chose, like, say, question 1 from the bank and question 4, okay? But from their bank of questions, that just lets us know where it came from. But it came from the 3.3 assignment. So this one says, the following data represents the number of people aged 25 to 64 years covered by a health insurance, it could have been private or governmental, in 2018. Approximate the mean and the standard deviation for this age group. So it tells us our ages, it grouped them, they're binned data. People are the age 25 to 34, and in millions, there were 24.9 million people. And then people from 35 to 45, there were 36.6 million. So anyways, we take and hit this little button right here for the StatCrunch, and then it opens it up, pulls the data into here. And then if we want to get that, come up with the mean and the standard deviation, you're going to hit Stat, and then you're going to do Summary Stats. We've done that one before, but instead of doing columns, that's the one I showed earlier in class, your data is now grouped or binned. They're in these intervals of data. So you'll choose the grouped or bin data, and then your bins are in, well, those were your ages, those were your groups. So then in this little drop down, you have to select the ages. And then the counts, these were your counts, and it says they were numbers in millions right there. So then you say counts in numbers, millions. That's like how many people were in that group. And then again, you can over here select the ones you want. The ones that are over here in white are the ones that are already pre-selected. So if you don't want all of those and you want to just select the ones you need for the question, you can just select those ones. I don't mind seeing extra, so I would just leave it as long as it's showing what I need, and I need the mean and the standard deviation, so it is going to give me that data. So then I can just hit this compute button right here at the bottom, and then it goes and tells me my mean, and it tells me my standard deviation. Okay, now on this one, I have showing what the answer in MATLAB says it is. So it says it's 45.02. But then here, my mean, it said 44.52, which was a little different. But on mine, I can click, it has a little green arrow. If I click there, it shows other answers the computer allowed. In the 45.52, that my StatCrunch is showing me was one of those other allowed answers. And then the standard deviation, it says the 10.22, which matched there, but other answers it also allowed was 10.08. So when you're doing these, depending on if you're using StatCrunch or if you were to do these like in your graphing calculator, the answers come out a little bit different. So when I first was going through these, I was doing them all in the calculator and not using StatCrunch. And then, and it was accepting my answers. But then I'm like, I noticed that it was giving this little green arrow, and I'm like, why is it accepting these other things? And then another teacher that had been teaching is like, because if you use it in StatCrunch, the program algorithm it's using is a little different, whatever, versus what the calculator is doing, so the answers are coming up different. And then if you use like the tables and charts, like on your reference sheets that you guys are allowed that I haven't started teaching you yet, those ones, when you pull the numbers from here, again, you get slightly different numbers. So StatCrunch is accepting different answers based on, like, were you using a graphing calculator? Were you using StatCrunch? Were you figuring it out by hand using these tables and charts? But as long as your answer is within whatever they're allowing, then you get the points, and they don't care which one of those answers you use, because the answers do come out a little different. And that really bothered me at first when I was trying to do all these, like using tables and charts and not using StatCrunch. I'm like, why? but it was just like whatever algorithm or whatever the program was using was slightly different.